Hey, fourth period, Shasta High School Math 2B. This is Mr. Roberts, and we're going to be working through the Chapter 5.2.4 packet. Um, the title of this is How Else Can I Solve It? An Introduction to something called the Quadratic Formula. So, in previous lessons, and actually over the course of quite a few weeks, right, we've been developing a lot of different ways to solve quadratic equations. And we started out with, simple ones where we've got like a perfect square. Like, for example, we might look at, you don't need to write this down, but we might look at like, x squared equals 25. Well, I can solve that by taking the square root of both sides. And when I do that, right, we introduce actually, let's look at this. If I take the square root of both sides, I introduce this. And I hope you remember this. It's not something I stress a lot, but I want to start making sure I make more of a deal out of it. But it turns out that if you take a number, square it, and then take the square root, that's exactly the same thing as the absolute value function. So I can replace the square root of x squared with the absolute value of x, and that equals the number 5. And like we said yesterday, looking inside, this thing inside, right, this value inside of the radical, inside of the absolute value, that could be either positive 5 or negative 5. So that's why when we're sitting here, I can rewrite this as x is either plus 5 or it's negative 5. So there are two values that make that true, plus or minus 5. So that's one simple way, right? Just using square roots, but because there's no linear term. And then we spent a lot of time dealing with factoring quadratics, and using the zero product property. So if I was to start out with A and try to solve this using the zero product property, I'm going to go ahead and create a generic area model. And in that, I'm going to place down in the lower left-hand corner my x squared. And then up here I've got my negative 7. And what I'm looking for are two values of x that have a product of two products that are terms of x that have a product of negative 7x squared. And when I combine them with addition, I have to get negative 3. Well, the problem that I have is, this is supposed to be x squared. I'm sorry. The problem that I have is that as I look at this, 7 is pretty limiting, right? It's only divisible by 1 in itself. So I'm playing with 1 or 7. One of them has to be negative. And in fact, it would. So if I just did, one of them being negative, I could have negative 1 and 7, or I could have 7 and, or I could have negative 7 and positive 1. Well, when I'm looking at that, if I add negative 1 and 7, I get just 6. And if I add negative 7 and 1, I get negative 6. So there's no way that I'm going to be able to build this target of 3x. So this is not factorable. This is something that I can't factor. And because I can't factor it, I know that the solutions to this equation have to be, if they exist, they have to be radicals, right? They have to involve square roots, and then we could write those in simplified radical form. So what happened? Well, we're gonna write down, this is not factorable. So the solutions involve square roots. So let's go to the part B. It says, hey, now solve this equation by completing the square. And that's something that we've gotten, I think, we're getting good at it. We're getting better at that all the time. So let's go ahead and write this down. So if I was to solve this by completing the square, I've got the x squared minus 3x. And I'm going to go ahead and add 7 to both sides right off the bat. So I get that that's positive 7. Now, what do I need to add to complete the square? I need to add, remember, if you think about this, I'm going to add negative 3 halves squared. So actually what I'm going to add to both sides is 9/4. So I'm going to add 9/4 to both sides. So let me give us just a little bit more room here. So I'll say plus 9/4, and this equals 7 plus 9/4. So at this point, I've created a perfect square trinomial on the left-hand side, and we've visualized that. We've looked at it in a lot of different ways. But I can now write this in its perfect square form. I can write this as x plus, and oh, it's actually going to be minus because when I break this out, it's -3/2 going each direction. So it's going to be minus, and then the square root of 9/4 is 3/2. This quantity gets squared. Now on the other side, I'm going to go ahead and combine those, and you know what? I think we can certainly add 7 and 9/4 manually, but if that's an impediment for you at all, if it's like if you're not comfortable with dealing the fractions, please don't let that stop you from doing the math, because mathematics is so much more than arithmetic. So if I'm looking at this and I want to add these, I could just grab my calculator and say add 7 plus, and then I would grab my fraction template. So alpha y equals, there it is, and I'm just going to add plus 9/4. And when I do that, I get 37/4, which just looks phenomenal, right? That's just great. So this together is 37 over the number 4. Now, the next step, of course, is to go ahead and take the square root of both sides. And when I do that, let me do this with the color here. When I take the square root of this side, and I take the square root of this side, right, the thing on the left-hand side becomes the absolute value. So this becomes the absolute value of x minus 3/2. And this should look familiar because we did this just the other day together. So the absolute value of x minus 3/2. On the other side, I'm going to simplify this root 37. This is the same thing as the square root of 37 divided by the number 2. So you can see what I did. I had root 37/4. Well, that's the same thing as root 37 over root 4, which is equal to 37/2. So now if I want to get rid of this absolute value, I have to introduce the fact that this thing inside could either be positive 37/2 or root 37/2, or it could be the negative of it. So let's go ahead and write that down. So this thing inside is either we're now looking at either x minus 3/2. I'm sorry, 3/2 is plus or minus root 37 over 2. And then as almost a final step, we're getting very close. I'm just going to go ahead and add 3/2 to both sides. So x is going to equal 3 over 2, and then, plus or minus root 37 over 2. And I want to take this out one more step. Because these both have the same denominator, they're both halves, I'm going to write this as x is equal to 3 plus or minus root 37, all divided by the number 2. So there's two answers there. One of them is when I'm looking at the plus root 37, and the other one when I'm looking at the minus root 37. And we got this answer by completing the square. So the next thing that we're asked to do is to graph this equation on our graphing calculator. So let's go ahead and grab it and set this up to graph it. I'm going to reset my calculator, and I suggest you do that because my Honors Math 1 students have been doing a lot of stats plots, and they could be messed up. So to reset these, the easiest thing to do is just to hit the second button and then hit the plus button and then enter the digit 712. So I'm just going to press second, and then plus, and then 7 and 1 and 2. And when I do that, it says RAM's cleared. So this all the stats, plots, and everything are gone. So it should be easy for me to graph this function. So I'm just going to hit y equals, and I'm just going to graph. I'm going to click this button to hit my x. It's right there. I'm going to square it. So that's x squared, and then minus 3x, and then minus 7. So x squared minus 3x minus 7. And if I hit graph, I can see it there. It looks fabulous. And it says, what does it say? It says, estimate the solutions to the original equation using this graph. Okay. So I'm going to estimate these solutions. So I think part of the problem, well, let's look at it. So if I move my cursor over here, I've got x is about negative 1.7. And if I come over here, I'm looking at 4.46. So let me write those two down, 4.46 and negative 1.17. So I've got an exact answer, which is superior in a lot of ways, but if I want to see these, if I want to see if the answers that I got for x are confirmed by this graph, let me go ahead and look at this. So I'm going to say 3, and then I'll do plus the square root of 7, and I'm going to, I want to clean this up. I'm going to enter this whole thing as a fraction. So let me show you again. I'm going to hit second. I'm hitting alpha, and then this y equal button, and I grab the fraction template. In the numerator, I'm going to enter 3 plus. I love how this ROM does this. This calculator is awesome. So I've got 3 plus the root 37, and then that's going to be all over 2. And I want to look at that as a decimal. And you can see I got 4.54. So again, this was just me trying to read this off the calculator screen. This is much more accurate. It's fabulous looking. Now, if I want to do the minus part, I can just come up here, grab this again, and all I need to do is go through and change in my numerator that plus to a minus. When I press enter now, you can see I've got negative 1.54. So my answers were not very. I should have zoomed in or something, but I would say certainly this is reasonable, and definitely one's over on the negative and one's over on the positive. Let me look at that graph again. That kind of. Well, yeah, it's close. Um, this definitely right here. This is not a close approximation. I was off there, but I can see that yeah, we're definitely in the neighborhood here. So okay, what's this point? It says graph it. Estimate the solutions to using the graph. Does the graph confirm your answer? Yeah, it certainly does. And in fact, I'm going to go ahead and do a little sketch here of this graph. If you could do a sketch also. And we know that this point right here is about negative 1.5, and this point right here is about at 4.46. So those are values of x that make this function equal 0. So that's approximately it. Okay, so let's move on now to question 96. It says the quadratic formula. One way to solve a quadratic equation is by using this thing called the quadratic formula shown below. Actually, it's off to the right. This formula uses a, b, and c from a quadratic equation written in standard form, explained in the next paragraph. Okay, standard form. When an equation is written in standard form, that is, it looks like ax squared plus bx plus c equals 0, then a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. Okay, so looking at the semi-equation that we have here, if we've got x squared minus 3x minus 7 equals 0, then what are the values of a, b, and c? I think we can handle this, right? So if I look right here, I don't see a number in front of a, so it has to be that it was the 1, right? So I would say that a is 1. We could say that b is negative 3. And finally, we would write down that c is the number -7. Okay, so we know what A, B, and C are. Okay, and that's all it asked me for. Let's move on to the next page. It says the quadratic formula calculates two possible answers by using this plus minus symbol. This symbol, read as plus or minus, is a shorthand notation for that tells you to calculate the formula twice, once with the addition and once with the subtraction in the numerator. Therefore, every quadratic formula problem is really two different problems unless the value of b squared minus 4 times a times c is 0. So what we're saying here is if this thing is 0, right, it doesn't matter if you added or subtracted, it's nothing. So really this just reduces down to the opposite of b divided by 2a. All right, okay, so now it says carefully substitute in the values of a, b, and c into the quadratic formula and evaluate each expression once, using addition and once using subtraction to solve for x. Do these match the solutions from problem 95? Okay, let's do this. So I'm going to go ahead and write this down here. I'll rewrite these again. So we knew that, I don't want to do it with a yellow highlighter though. We had that A was equal to 1, B was equal to -3, and C was equal to -7. So the quadratic formula, let me write that down also, x equals the opposite of b plus or minus, then we're going to have the square root of some stuff. The square root of, we're going to square b, and then we're going to subtract 4 times a times c, and then we're going to divide that entire thing by 2 times a. Okay, so let's do our substitution here. And I'm going to be pretty careful about using parentheses. So x is the opposite of b. So here is b. So I'm going to put the opposite of -3. And then I've got plus or minus the square root of. Inside of the radical, I'm going to take b and I'm going to square it. So I'm going to write -3 in parentheses squared minus, and then I'm going to have the 4 times a, which is a 1, times c, which is a -7. And I'm going to divide all of that by 2 times a, and a is just 1, so 2 times 1. All right, there we go. We've got that. And what's nice is that our calculator can handle this pretty well just as it is, but I probably should simplify this before I grab the calculator. So let's go ahead and simplify it the best we can. So we'll write x is equal to, first of all, the opposite of -3 is just 3. So we're going to write x is equal to 3, and then we're going to have plus or minus. And then -3 squared, that's -3 times -3. That's clearly just the number 9. We're going to have 9. And then you can see there's a -4 and a -7. So -4 times -7 is positive 28. So I'm going to have plus the number 28. And in my denominator, I have just the number 2. And yeah, you guessed it. Maybe you see it. If I take and I add 28 plus 9, it gives me exactly 37. So what this is, if you look at it, is now x is equal to plus or minus, or I'm sorry, 3 plus or minus the square root of 37, all divided by 2. This should look very familiar because if we just go back a little bit, it's exactly what we got, right? Exactly what we got when we solve this by completing the square. You can see the 3 plus or minus root 37 over 2. So there we got it by completing the square. And down here we got it by using the quadratic formula. So there must be some relationship between these two, or maybe completing the square is how we get this quadratic formula. All right, so let's look here. There's four problems here that you're asked to do. And I would say we should do two of them, and you're going to do two of them. So let's go ahead and do let's do B, and maybe we'll do C also. So let's do B. So again, please make sure this is in your notes exactly. This is a point if it's there correctly, and then of course more points when you do the other ones independently. So let's do B. So on B, the first step we're going to do is we're going to identify A, B, and C. And we know that A was the coefficient of our quadratic term, or x squared. We know that B is this coefficient of x, so it's a -9. And C is my constant term right there. So I can see A, B, and C, and I'll write them down. A is just +2. B is -9, and C is -35. Okay, so I'm doing this just kind of for practice because we should probably get to where we memorize this, but I'm writing x is equal to, and then the opposite of B, and then I've got the plus or minus, and then the square root, and inside of here we're going to write B gets squared minus 4 times A times C, and this entire thing is going to be divided by 2 times A. All right, so in the numerator, again, we're just going to plug in these values very carefully. So we're going to write x is equal to the opposite of -9. So you can see I've placed B in, right? B was -9, and I've placed it in the parentheses there, plus or minus the square root of, and again, B is -9, and we're going to square that, and then minus 4 times A, which was 2, times C, which is -35. And all of this is going to be divided by 2A, so that's 2 times 2 this time. Okay, let's clean this up. So x is equal to 9 plus or minus. Now, when I square -9, I get 81. So plus or minus the square root of 81. And then I've got, it's a -4 times 2 times, and I'm hitting the negative button there, for 35. This is like, oops, 35. So this is like 4 times 70, which is 280. So I've got plus 280, and all of that is going to be divided by the number 4. So when I add 280 with 81, I get the number 361. And unfortunately, or is it fortunately, 361 is a perfect square. That's 19. So I was just checking it off screen. I couldn't do that without my calculator. Sorry, just being honest. So we have now that this is, probably we'll move up here a bit. This is equal to, x's are equal to 9 plus or minus the square root of 361, all divided by 4. X's are equal to 9 plus or minus 19 over 4. So there's two answers here. At this point, I'm gonna use my calculator. I'm gonna go 9. Actually, I'm gonna do this as a fraction too. So second, I hope you guys are practicing using this fraction key. It's amazing. So I've got 9 plus 19 in my numerator over 4, which is 7. So x is, yeah, of course, 28 divided by 4 is 7. And if I come back up here and let me grab this again, and I'm just going to go in and edit that addition to a subtraction problem. So now it's 9. Oh, that's going to be -10 divided by 4, which is -5/2. So x is also equal to -5/2. So these are my values of x, and they should make this quadratic equal to exactly 0. And there's a really good way to check that. If I go ahead and graph this function, I would enter 2x squared and then minus 9x, and then minus 35. And if I graph that, I believe that when I enter in 7, I should get 0. So check this out again. If you hit trace and then say, oh, here's 7, what's y? Boom, it's at 0, right? And you can see it's flashing right there at the root. So when x is 7, it definitely makes this function equal 0. And the other thing that should happen, make that true, is 5 halves. So I'm going to hit this, whoops, trace again, and I'm just going to hit negative 5 over 2. It's beautiful, negative 5 halves, and boom. There it is, it's flashing on, and it definitely makes this function 0. So these are the two values, 7 and negative 5 halves, that truly make this equal exactly 0. So it's just, life is beautiful. All right, so that, and then one more over here. C. So same game, right? We're going to identify A, B, and C. And A, of course, is, in this case, A is equal to 8, and B equals 10, and C equals 3. So I'm going to write x equals opposite of B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. So x is equal to, in this case, the opposite of 10. So it's negative 10 this time, right? Because this is positive. So negative 10 plus or minus the square root of, oh, you know, I can just do this. 10 squared is 100. And then minus 4 times 8 times 3. Ooh. That's 8 times 12. And 8, oh, that's not right. And 8 times 12 is 96. Okay. So, all divided by 2 times 8. So this is x is equal to negative 10 plus or minus. This is equal to, it's 100 minus 96. Write that down. 100 minus 96, which is just, it's 4, right? All divided by 2 times 8. So that's x is equal to negative 10 plus or minus the square root of 4 over 16. Almost there. Negative 10 plus or minus 2 all divided by 16. So there's two answers for x, and I think I can see both of them. Let me not take any room away from that problem. One of them is x is equal to negative 12 over 16, and the other one is x is equal to negative 8 over 16. Those are both reducible, right? Those both have common factors. Negative 8 over 16 is, that's negative 1/2. So that's one of my values of x. Let me cross this one out. And the other value of x, 12 over 16, I know it reduces. Oh yeah, it reduces to 3/4. So x is 3/4. Okay, so I'm going to leave it here. I just have to say, I did not think that this would be this long. This is a full day, just these 2 pages on their own. So what I want you to do in the time that remains in class is I want you to do D, and I want you to do A. So take some time. Keep referring to the examples that we did, but it's just a matter of identifying A, B, and C, plugging them into the quadratic formula, and then evaluating.